Okay, welcome to the June 2025. This is the Edexcel GCSE paper 2, the higher tier paper. This is a calculator paper, unlike paper 1. Alright, question number 1, writing 250 as the product of its prime factors. I have split that up into 25 and 10, which splits up into 5 and 5 and 2 and 5, so it's 2 times 5 cubed. For B, finding the lowest common multiple, you can list them. You don't have to list them too far if you want to. I've written 30 and 25 as the product of its prime factors, and then taken the greatest number of prime factors for each one of those. There's 1, 2, there's 1, 3, and there are 2 5s in 25, so I'm going to take 5 squared. So 2 times 3 times 5 squared. So the lowest common multiple is 150. If you listed them and got 150, that's absolutely fine. For question number 2, we're dividing in a given ratio, so we've got 6,900. I'm going to divide that by the sum of the parts, 2 plus 3 plus 5, which is 10, so each part is worth 690. To find 2 parts, we therefore double 690, which is 1,380. To find 3 parts, we triple 690, which is 2070, and to find 5 parts, times it by 5, 3,450. And so Sid, Tam, and Musa are splitting the money, 1,380, 2070, 3,450, like so. Question number 3. We want to find the shaded area, essentially. So we've got a base and a perpendicular height. So to find the area of the triangle, including the circle, it's a half times 16 times 14. Then I'm going to subtract the area of a circle. The radius is half of 7. So I'm calling that 7 over 2. Pi lots of r squared, pi lots of 7 over 2 squared. Subtract that and we get the shaded area, 73.515, etc., etc. Dividing that by 12.5 to work out how many bags we need. So we need that area divided by 12.5, which is 5.8 something, 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 something. We'll only be able to buy a whole number of bags, so we need the smallest number bigger than 5.8, whole number, which is 6. Now, if each of the bag only covers an area of 11, well, 6 lots of 11 would give you 66 square meters. That won't be enough to cover the 73 and a bit square meters that needs covering, so there won't be enough. Basically, Maxon will need to buy more bags. In fact, one more bag would do it. Question number 4. So because it says at least 2 centimeters, that's 2 centimeters or more. That's going to represent the area outside the circle, not inside the circle. So poor Nadia has shaded the inside of the circle instead of all of the area outside of it. Question number 5. It's a fifth less, so that's to find something that is a fifth less, you multiply by 4/5. If you want to reverse that, then you're going to divide by 4/5. 8,000 divided by 4/5, or 0.8, comes out as 10,000. 10,000 tons is the correct answer for 5. For number 6, we're calculating means. So to find the mean of list A, we're going to sum together the 4 terms in list A and then divide them by 4. And that comes out as a nice round 243. Then we know that the ratio of the means is 3 to 5. So if I divide 243 by 3 and then times it by 5, it gives me the mean of list B, which is 405. It allows me to construct an equation for calculating the mean of list B. So I sum together all of the values inside it, divide it by 6, because there are 6 values, and I know that that calculation is going to come out at 405. Then solve the equation to find x, so times both sides by 6. Collect all the numerical parts together. We get 2060 plus x equals 2430. In this case, x must be 370. For 7, SOHCAHTOA, 7 is the opposite, 4 is the adjacent, so tan of x will be 7 over 4. The opposite over adjacent, x will be inverse tan of 7/4, which is 60.33 when rounded to 1 decimal place. Question number 8. We know the density is 8 grams per centimeters cubed, so if we multiply that by the 1500 by the volume, it will give us the mass. In this case, 12,000 grams. Turning that into kilograms, divided by 1,000, we get 12 kilograms. And so if we divide the maximum 300 by the 12 kilograms per rod, it tells us we can put 25 safely onto the trolley. Question 9, expanding out, add the powers with the x, so 3 times 4 is 12, x to the minus 1 times by x to the 1 is x to the 0, which is just 12, because x to the 0 will be 1, and the other part will be minus 3x squared, so a is 12, b is negative 3, n is 2. Solve the equation. The first step, multiply both sides by 3, add x to both sides, divide both sides by 10, and we get x equals 1.4, or if you prefer something like 7 over 5 as a fraction, 1 and 2/5 would be absolutely fine. Question 11, the probability tree, so just pairing them up and knowing they add together to make 1, we can fill it in 0.2, 0.15, 0.85, 0.15. Probability that only one of them, so that's a pass-fail or a fail-pass. Multiply those probabilities together and then add them, we get 0.29. Okay, for the box plot, first thing I do, I'm going to draw the vertical lines for all the critical values there. So we've got 2180, 3142, 35. And then I put the 2 middle bits in for the 2 sides and then create the box in the middle. You don't have to do it in that order, but it's quite a nice way of doing it. Between 31 and 42, those are the 2 quartiles, so it's going to be half of the actors. There are 32 actors in total, so half of 32 is 16. Now, Mary makes a claim about the median and saying that at least one of the actors has to be 35 because that's the median. Well, that's not true. Because there are 32 actors, it is quite possible that the median is 35, but actually none of the actors are 35 themselves. When you have 32 pieces of data, the median is going to be halfway between the 16th and 17th. And so as long as the 16th and the 17th actor, the average of their 2 ages is 35, the median will be 35 without necessarily any of them being 35. So I'm afraid, Mary, you're not correct in this case. It could be possible that there is a 35-year-old actor, of course, although we would need there to be 2 of them if that were the case. Question 13, that's expanding triple brackets. I've picked the first 2, expanded those, and then multiplied it by the last one. It doesn't matter if you've done it in a different order. You could pick any 2 of the 3, expand those out, and then multiply each part by each part in the other. And then at the end, I've collected all of the like terms, collect the same powers of x together, we get 2x cubed plus 5x squared minus x minus 6. It's not necessary to write them in descending powers of x, but it is much prettier. For 14, so 15 dogs, so first and second prize is 15 times 14. For the cats, there's going to be 12 times 11, and therefore overall is a multiple of all of those, 27,720 different ways of awarding the prizes. Okay, for the grid, I've drawn the 4 lines that they've given us. like so, and then you can pick a point and shade them. So I've shaded everything to the right. That's the line x plus y is less than 5, and then y is greater than 1, so I shade everything where y is less than 1, shade everything where x is less than 2, and we can see we're left with that little region that's unshaded there, which I'm going to label R. The y is less than 3x minus 2 had no impact on the shading at the end, and so could have been ignored with no change. Okay, for 3D similarity, we're given a scale factor of volumes. We know we've got 90 to 1350. First thing I'm going to do is simplify that ratio. 1350 divides nicely by 90, so that ratio is 1 to 15. To go from the scale factor of volumes to the scale factor of lengths, we cube root everything. Cube root of 1 is 1, the cube root of 15 is the cube root of 15. So to find the height of the smaller jar, we'll divide 12 by the cube root of 15, which on a calculator comes out as 4.9 centimetres when rounded to one decimal place. To jump from scale factor of lengths to a scale factor of areas, we square both of them. 1 squared is 1. The cube root of 15 squared is the cube root of 15 squared, or if you prefer 15 to the power of 2 over 3. So you'd multiply an area by 15 to the power of 2 over 3 to get a new area. So in this case, P must be 15 to the power of 2 over 3. It wants the exact value. Question 17, we've got a negative exponential curve. We know it goes through minus 1, 1.5, so I'll substitute those into the equation. K to the power of minus 1, well that means 1 over k. Multiply both sides by k, divide both sides by 1.5, and then 1 over 1.5, I've doubled the 1 and doubled the 1.5, so we've written it as 2/3, so k is 2/3. Question 18. So we have an iterative formula. We know it jumps from 2000 to 2400 in the question, from 2019 to 2020. So we use that to work out k, dividing both sides by 2000. We know that k must be 1.2 here. Then to work out the 2022, well, we have the 2021, so we take the 2020 population and multiply that by 1.2. It will get us the 2021 population. So 1.2 times 2,400 means that there are 2,880 for 2021. And then for 2022, we'll take that and multiply again by 1.2. And that comes out as 3,456. And 3,456 is conveniently greater than 3,000, which is what the question's asked us to show. Okay, for question number 19, the angle GEB is the one that's inside the shape, so I'm actually going to mark it on there. That's the angle that I'm going to call theta. To find theta, we're going to need two lengths on the triangle BGE. So I'm going to calculate GE and BG one at a time. For getting GE, cos of 52 is going to give us FE over GE. Quick rearrangement of that, we can get G is 15 over cos of 52. Similarly for BG, looking at the triangle BGH, BG is the opposite on that one, so we can do 15 tan of 27, gives us 2.54, etc, etc. And then to find the angle we're looking for, we can do inverse tan of those two values. Try not to round your answers partway through. You can use in this big fraction the expressions for BG and GE, 15 over cos 52 and 15 tan 27. Either way, it comes out as 17 degrees when rounded to the nearest degree. Question 20. We're told that the ratio of A to D to D to B is 1 to 3. And so D is going to be a quarter of the way along from A to B. So the x value is going to be sort of a quarter of the way between 0 to 16, which is a quarter of 16 is 4, so it's going to be 4 up. And the y value of D is going to be a quarter of the way from 8 down to 0. Well, a quarter of 8 is 2, so it's going to be 2 less than 8. And so we can work out this coordinate D as being 4, 6, which I'll mark on there. To find our equation L, well, we know that the gradient of L is root 3, so y equals mx plus c, or y equals root 3x plus c. We know that passes through D, so I can substitute y for 6 and x for 4, so 6 equals root 3 times 4 plus c. Subtract 4 root 3 from both sides, we get c to be 6 minus 4 root 3. Therefore, the equation of L is y equals root 3x plus 6 minus 4 root 3. To find the coordinate f, well, we know x is negative 2, so we can substitute y for f and x for negative 2. F is going to be equal to root 3 times negative 2 plus 6 minus 4 root 3. And therefore f will be equal to, collecting the root 3's together, 6 minus 6 root 3, which is indeed less than negative 4. You can plug it in and work that out if you want to. For 21, so we're looking at two critical values, negative 2/5 and a third, and because it's less than 0, that's when the quadratic is below the x-axis. It's going to be the values of x that are in between those. If you can visualize it like that, it's much easier. You can test points, you can draw graphs, a number of ways, but negative 2/5 is less than x is less than a third. So question 22. Apologies for my circle here. I'm sure you'll have used a pair of compasses and have drawn a far superior circle to mine. It's shifted down 2 places, so its centre is no longer at 0, 0. We know the radius is 5 because it's the square root of 25. And so our 2 other points are 0, 3 and 0, negative 7. And I can only apologise for that. I mean, that's appalling. But something like that is what the question is looking for. Question 23, we've got ourselves a quadrilateral. I'm going to immediately split that up into 2 triangles. This question is to do with trig. Let's label those 2 angles theta 1 and theta 2, and we'll calculate them separately and add them together at the end to find the angle that we want. Finding the length BD is going to be critical here, so I'm going to use a cosine rule on the triangle BCD. So a squared plus b squared minus 2bc cos a, and square root all that. And that comes out as a square root of 117. You can work that out if you want to. I'm going to leave it as the square root of 117 to avoid rounding part way through a question. You can always type the square root of 117 into the calculator whenever doing these sorts of questions. So now switching to the sine rule in the bottom triangle, we've got sine of theta 1 over 9 will be equal to sine of 60 over root 117. So to find theta, I'm going to bring the 9 up to the right hand side and then apply the inverse sine function. So theta will be inverse sine of 9 sine 60 all over root 117. When you do that, you get 46.1 degrees. When I do the final calculation, I actually use I sum these 2 calculations together to avoid having to do any rounding. For the triangle at the top, sine of theta 2 over 6 will be equal to sine of 125 over root 117. So bring the 6 up to the top right, exactly the same as the first one. Theta 2 will be inverse sine of 6 sine 125 all over root 117, which is 27.0 something something something. And then we can add our 2 angles together. To the nearest degree, that's going to round to 73 degrees. Well done if you got that. All right, bye.